Welcome back. We are going to continue in section 4.5, unit 1. We're going to finish it up by solving equations now. We learned how to simplify radicals in the first section. Now we're going to solve quadratic equations by using square roots. So this is another method that will work for some, but not every single equation we come across. Okay, so first things first, solve the equations by taking the square root of both sides of the equation. Solve for the variable, and there are always two solutions. So make sure you have all that down as a reminder, and I'll show you why we have two solutions here. If I have these individual equations, these are about as simple quadratic equations as we're going to get that we can solve with square roots. But my goal is to isolate the variable. I always reverse order of operations. PEMDAS, please excuse my dear Aunt Sally, we reverse it. So you've heard me mention this before, please excuse my dear Aunt Sally, and I hope you've heard that before. When we solve, we reverse it. We do SAD method. So we start with subtraction, addition, then we undo division, multiplication, then we do exponents, and then we go inside parentheses. There's nothing being subtracted or added in any of these. There's nothing being divided or multiplied, but there are exponents. How do we undo exponents? How do we undo squaring something? So in order to solve for the variable and x squared equals 36, what undoes squaring? Think about your graphing calculator. If you hit second x squared, it's the square root sign. So we take the square root of 36. What is the square root of 36? Well, on your calculator it says 6. But is that our only solution? Well, let's test this out. 6 to the second power is 36. What happens when I do negative 6 to the second power? What do I get? I get positive 36 as well. When we're simplifying a radical expression, we do not worry about negatives. And that's the rule with it. When you simplify a radical expression, you always assume it to be a positive when you simplify. When we're solving, however, as soon as you square root both sides of an equation, you've now given yourself two answers, two solutions. Okay? And we can verify this by graphing it. X squared equals 36. Okay? So we'll do y equals x squared in here. That's what y equals x squared, and we'll graph it. 36. We said 6 and negative 6. Let's go to the table. At positive 6, we get 36. When I go back up here to negative 6, I also get 36. So it comes out to be an answer in both spots. It repeats. So that's just something we have to be aware of. When we square root, the calculator is only going to give us one solution. It's only going to give us that positive solution. You have to do 6 or negative 6. And then when you get really good, what I'd like you to do, you can just write it this way. Plus or minus, that's what this symbol means, 6. That's the same thing. Okay? So either way, either write x equals 6 or x equals negative 6, or just write plus or minus 6. So let's go through the rest of these real quick. When you square root both sides, the square root of 1 is 1. So n equals 1, or n equals negative 1, or plus or minus 1. Square root 8. This is why we learned how to simplify these yesterday. The radicals. C equals plus or minus the square root of 8. What's a perfect square that divides 8? Make your list of perfect squares. 1, 2, 3, 4, 5. Square them. 2 squared is 4. 4 does divide 8. Make your list. Plus or minus square root of 4. Excuse me, square root of 4 times square root of 2, or plus or minus 2 square root of 2. Plug in your calculator if you don't believe me that it's the same thing. But we practiced that yesterday, so go ahead if you need to. Finally, square root k squared, square root of 45. If you look at your list, the biggest number that divides 45 is 9. It's a perfect square. Remember, they have to be perfect squares. So plus or minus square root of 9 times the square root of 5. The square root of 9 is... So plus or minus 3 square roots of 5. Okay? Like I said, go back, check in your calculator. Graph it, see if it works. Same thing we did for x squared. Okay, if you forgot or need it again, go back and watch what I did. Again, rewind it. Okay? So let's solve some of these. Let's get some practice in solving. In order to solve it, like I said, we reverse the order of operations. We SAD map. So as we go through this, as you know, for the previous lessons, we start with the simplest way to do something, or simplest type of equation, and we work our way up to more difficult ones. So now we've added in a number or coefficient in front of the variable. We have to get rid of those numbers that are being multiplied by the variables, or subtracted from the variables, or added to the variables. So in this case, 7 is multiplying. How do we get rid of that 7 in front of p squared? We divide both sides by 7. So in your calculator, 448 divided by 7, well, that's 64. How do we get rid of the squared? We square root both sides. If you square root in your calculator, you get p equals 8. What am I missing? You're missing a negative 8. Because remember, negative 8 times negative 8 also makes 64. So plus or minus 8. As soon as you square root both sides of an equation, you have to have the plus or minus in there. Okay? Once you guys try this one, 5p squared equals 80 on your own, pause it, try it, and then come back when you think you have the answer. Okay, this one, same idea. We have to undo multiplying by dividing both sides. 80 divided by 5 is 16. So we square root both sides. Got ahead of myself there. Square root both sides. We get p equals plus or minus 4. Okay? Let's try a different looking one. What if we're adding or subtracting? Same thing. Well, I keep writing SAD map up here to remind you, reverse the order of operations. So t squared plus 6 equals 127. G squared minus 7 equals 29. Pause it. Try both of these on your own. We're going to do t squared plus 6 equals 127 first. Let's do that one. And when you get done with that one, check it to make sure you're doing it right, and then try the other one as well. Okay, so this case, I have something being added to t squared. How do I undo adding it? I subtract. Subtracting will cancel it out. So t squared equals 121. I square root 121. T equals plus or minus 11. Hopefully that came out what you got. Remember, you always check your answer, and I didn't do it on the other ones, but let's plug it back in. 11 squared plus 6. 11 squared plus 6. I get 127. And negative 11, when you check the negative ones, remember you got to put them in parentheses or else you're not going to get an answer you like, is 127. So that's how I would check it. That's my check. Plug it back in. I use a calculator check. You would have to write it out by hand in the quiz, unfortunately, because there's no printouts for your calculator, but it's what you would do. You would write down this and then just plug in your calculator and get the answer. I'll give you a minute here to do this one as well if you haven't already. Pause it. Come back when you're ready to check your work. Okay, this time we're subtracting 7, so we undo it by adding 7. G squared equals 36. Square root both sides. G equals plus or minus 6. Do the same thing, plug it in. 6 squared is 36, minus 7 is 29. Negative 6 times negative 6 is 36, minus 7 is 29. So please do that. I didn't plug it back in and check, but you would do the same thing we did over here to check plus or minus 11. Okay, so now we're just going to move up. We're going to do two-step equations. Okay, we're going to do two-step equations. No big deal. And notice as we've gone through this, we can do solving by square roots because there is no linear term. There's no m, in this case, m to the first power or x to the first power. That's when you can solve by doing square roots. If I had a trinomial here, I cannot solve by square roots in the form it's in right now. Okay, so you have to have one squared term. No other m's can be in there, or x's, or whatever variable we're working at. Just wanted to point that out. So I'll give you a second once you guys see if you can do this one on your own before I do it. I should be picking up on it. So pause and then come back when you're ready. Okay, so now PEMDAS. Hopefully you wrote that down. Oops, not PEMDAS. SADMEP. We want to reverse PEMDAS. Not PEMDAS. SADMEP. So something is being subtracted and added. This is why I write that down, because what do I do first? The 2 or the 15? This is where people start freaking out and they get algebra nightmares. Okay, write that down. SA. That stands for subtraction, addition. That's where we start when we're solving. I'm going to undo subtracting 15 by adding 15. 15 plus 65, that's 80, I believe. And then we divide by 2. Then we move down. Division and multiplication. And division, multiplication, subtraction, addition, they're equal. You can do them. There's no priority over either one of them. Okay, they're kind of equal footing on each step. Need to remember that from the order of operations. So I get m squared is 40. Square root both sides. Uh-oh, that doesn't work out so well, does it? Oops. Plus or minus the square root of 40. 40 can probably be broken down, though. Hopefully you made your list of perfect squares. We'll just go to that. If we have to continue it for the next one, we will. 1, 4, 9, 16, 25, 36, 49, and 64. We're way past it, right? So 40 would be right about here on the list. 36 won't divide it. 25 won't divide it. 16 won't. 9 won't. But 4 will. Remember, you always want to do it systematically. Try and find, even though 4 was the first one, so I could have just started with 4, Mr. Coon. It would have worked this time, but maybe not on a different problem. So square root of 4 times the square root of 10. 4 times 10 is 40. We get plus or minus 2 square roots of 10. Check and see if it works. Plug it back into the original equation. Okay, plug it back in. You can do it. I will show you how to do it. Just at least with one of the solutions. To plug it in here, we have 2 times, instead of m, we're going to put 2 square roots of 10. See, I can plug it in just like that. If I put it in parentheses, we're good. Squared, I got to square it though. Minus 15. If I get 65, we're good. Enter. We get 65. So you can plug it in to check, and then of course you would check negative. But the negative, hopefully we're seeing the pattern, it will work out. Okay? So that's our check. See how that calculator can be your friend for checking real fast? Okay, if you haven't tried the other one, pause it now and get back to me when you're ready to check it. This one's almost a mirror image of the other one. It's the same. It's a negative constant term here being next to the m, so we're subtracting 35. We have to add it. We add 35 to both sides. We add 35 to 365. We get 400. Divide both sides by 4. M squared equals 100. Oh, we're real happy now, aren't we? Because what's the square root of 100? Plus or minus 10. Plug 10 back into your answer. Minus 10 back in. You should check both. You don't want to check one, but check both because it's important that you make sure you're getting the right answers in both ways. Okay? And last but not least, difficulty here, we're going to, what if we have something in parentheses being squared, equal a number? Well, we can use square roots to solve this one. Now, this also means x minus 5 times x minus 5, right? Some people might write this out, FOIL it, then move the 10 over, subtract that, set equal to 0, and factor. Could you do that? Yes, you can. That would work. That's fine. If you really like factoring, do that. I am not going to do that way, however, because we have this new tool. When it's a perfect square like this, we can use solving by square roots. So that's what I'm going to do. I square root both sides. You mean I can square root the entire parentheses? Yes, I can. Remember, reversing PEMDAS, we get SADMEP. Exponents are undone before parentheses. How do I undo square root 2? I square root 2, which means I have to then square root 10. these cancel each other out. I get x minus 5 equals plus or minus the square root of 10. Is that done? Well, is x by itself? That's what you got to ask. If I'm solving it, it's x alone. Is x isolated? It's not. I'm going to undo subtracting 5. I add 5 to both sides, and I get 5 plus or minus the square root of 10. The only thing I want to do with the square root is make sure that it's simplified. But when you compare the square root of 10 to a list of perfect squares that you already have on your paper, I'm sure, 10 cannot be divided by 4 or 9, or, well, 1 it will be. 4 or 9 won't work, so that's it. Once again, plug it back into your equation. See if it will work. Okay, if you're wondering, I can't only do this with my calculator, I don't know. I'll do it once for you. Okay? Don't freak out on me. We have 5. We're going to use double parentheses here. Okay? Because we're putting 5 plus the square root of 10. Minus the square root of 10 should work as well. Square root of 10. We're squaring. But we didn't need double parentheses. Let's try this again. We only needed 1. No, we did need double parentheses. That was right. Looking at something else. We want to do 5 plus the square root of 10. We have to arrow out. That's what I need. We have to arrow outside of that to get that parenthesis. Otherwise, if you notice, if I didn't arrow out, it just keeps inside the parenthesis, and that's not going to work. So when you get to the end of your square root and you want to put a parenthesis around it or something else outside of it, you have to arrow to the right to get it to work. Minus 5, and we're going to square it. Do we get 10? We do. So just using parentheses, you can get around these complicated, irrational expressions. You can put them in your calculator and still see if they work. Once you do this other one over here, x plus 4 squared equals 7. Pause it. I'll give you a minute to try that on your own, and then come back when you're ready. Okay, so hopefully you didn't FOIL it out. Hopefully you did like what you did in the last problem. X plus 4 squared equals 7. We undo the squaring by square rooting both sides. X plus 4 equals the square root of 7 plus or minus. Don't forget that. That's key. Are we done? Well, I don't see that x is isolated, so I've got to subtract 4. So x equals negative 4 plus or minus the square root of 7. Go ahead and check it when you're done. You can also graph. You could graph it. See, it's gonna give you a decimal when you see where these lines cross, but you can approximate it as a decimal and do it that way. In fact, I'll show you how we can do that. Let's do this. Let's check it with the graphing calculator. X plus 4 squared equals 7. Go to y equals. Yeah, this works for really any type of equation you want to solve, not just quadratic. So if you don't know how to do this, this could be a good lifesaver, I should say, on for instance, ACT test or a final exam. If you forget a particular method for solving, the graphing calculator can help you out. So I take the left side, which is x plus 4 squared, and put that in y1. See how that was on the left? And then the right side was 7. And I graph it. So I get a quadratic, and I get a line. See where it crosses twice? And sometimes you may have to change your window. If you hit zoom out, you can hit zoom out until you can see it on your window, but we already see it, so we're just going to leave it on graph. It crosses. The two spots where it crosses on the graph, those are your two solutions. So we just do our intersect. Second trace. We want to find the intersect. Oops, that's not what I want. And you can do this to find the zeros as well. Intersect. First curve, enter. Second curve, enter. Guess. We want this first one, right? Enter. Negative 1.35 and 7. Well, let's see if negative 1.35 is one of our solutions. When I bring this out, I have negative 4 plus the square root of 7 and negative 4 minus the square root of 7. So negative 4 plus the square root of 7, what is that as a decimal? Plug it in your calculator. Negative 4 plus the square root of 7 is negative 1.35. Same thing. So that's one of our solutions. Now if we want to find the other one, let's go back to the graph. Second trace, you go down to intersect, because we want to see where these two lines, these two graphs cross. Or you can just hit 5, you don't have to arrow down. We're going to hit enter, enter, and our guess, this time we have to arrow over to this other one. You have to get close to it, so it doesn't click on the same answer, because we already know what that first answer on the right is. We're going to get this left answer now. Can we get negative 6.64 and y equals 7? So let's see if that's one of our solutions. The only solution we have left is negative 4 minus, oops, not plus, minus the square root of 7. Let's turn this page on. Let's see if that is the same decimal as negative 6.64. So on our calculator, we do negative 4 minus the square root of 7. You say, Mr. Coon, why do we need to do this? This is just another way to check. Negative 6.454. So we can see that both negative 4 plus the square root of 7 and negative 4 minus the square root of 7 give us, let me go up here and get it, the two answers, the two intersection points. We proved it graphically, we checked it graphically with the calculator, and they were equivalent decimals as the square roots that we have here. So just another way to do it. Okay, sorry, I like showing multiple ways because I don't know which one you're going to like. So wrapping this up, were we able to accomplish our target for today, our goal? Were we able to solve quadratics using square roots? I think I showed that we can do that. The ones where you can do that, the problems that you can use this method for are ones that just have a squared term. They do not have an x, for instance. You just a squared term. You can have constants in there, but you cannot have a squared term. And you can solve by square root. So make sure you have your notes all complete. We'll be checking on tomorrow. We'll see you tomorrow.